Okay, so to understand the technique on how to find a 4x4 determinant, we're going to backtrack and we're going to start off with smaller determinants and sort of build up into that. So I'm going to do a little bit of sort of algebraic expansion ideas, and then I'll actually go in and do a couple examples just to kind of give you a sense as to how this thing works. Okay, so let's start with a 2x2 determinant. 2x2 determinant we define as the product of A times D minus B times C. So I always like to think of it like the slide technique. So what do little kids do when they see a slide? They like to climb up and go down it. So they climb up here to A, they go down the slide, they get so excited they get back on it again, so they come up this way and they go down it that way. Now, all that said, the determinant for a 2x2 is just the product of those numbers, so AD minus BC. Okay, so that's fine, but how does that affect a 3x3? Okay, so let's look at a little bit bigger one. All right, so what we've done is we've done sort of an expansion of the 3x3 into smaller 2x2s. So we start with A that we are going to multiply by the determinant of this connected 2x2, this minor form of the 3x3 that's related to A. So let me kind of illustrate kind of how we recognize this. Okay, so to figure out what the determinant that goes with A is, I cover up the column and the row associated with A, and the leftover piece, this EFHI, that's what we're going to multiply by the A to get that particular value. Okay, so then we start off with A, and we're going to go to B, and with B, we're going to sort of alternate signs. So A has a plus, B has a minus, C is going to have a plus when we finally get to it. But let me cover up the stuff associated with B. Now in this case, I got a box there, and I have another box on the other side. Oops, too big. Okay, so once I cover up the row and column associated with B, I'm left with the other set of numbers, so DGFI. All right, and then the last one is C. So again, we're going to cover up the row and column associated with C, and whatever remains is what would... Sorry, inserting these little pictures. You'd think I'd be better at this. All right, so whatever remains, once I've covered that up, is going to be the matrix that we will multiply C by, with the determinant of it to multiply that by. Did the same thing last time. Okay, so you notice we're left with DEGH as far as that goes. Okay, so when all said and done, that's the expansion of a 3x3 into a series of 2x2 determinants. Again, each 2x2 is the positive product minus the negative product. Well, that makes sense. So like in each case, so it's EI minus FH, this would be DI minus FG, this would be DH minus EG. So we're gonna do an example, put some actual numbers in here, and actually talk about some smart approaches that you can usually take with finding determinants of 3x3s. Okay, so in this 3x3, we're gonna find its determinant. I'm gonna show you kind of two approaches. So first, I can just do the 1, 2, 3 approach. So I could just go, well, that's 1 times the determinant of and then cover, basically cover up row and column. So in that case, it would be 4, 5, 0, and 3. Then I want minus the 2 times the determinant of, okay, so what are the numbers associated with 2? That'd be 0, -2, 5, and 3. 3, plus 3 times the determinant. And this time the 3 has 0, 4, negative 2, and 0 connected with it. Okay, so I'm going to speed this process up so you can kind of see if once we expand it out what we get. But let me just kind of start the expansion. So 1 times, and then it's 4 times 3 minus 5 times 0 is the first piece, minus 2, 0 times 3 minus 5 times a negative 2, plus 3 times 0 minus 4 times a negative 2. All right, so I'm going to pause this and work out the little calculations here. Okay, so just show you what I got here. So once I multiplied and subtracted, I got this string of numbers. And so finally I end up with this magic number 16. Okay, so the determinant of the original 3 by 3 happens to be 16. Okay, now let me show you a different expansion of this because you don't have to go across. You don't have to do 1, 2, 3, that top row. You can actually do down, or you can do a bottom row or the middle row. But you have to keep in mind that when you, however pattern you pick, it's positive, negative, positive. It's like an alternate signs as you set up your expansion, but there's value in looking at a slightly different row. So for example, I see row 2, I have a 0 right there. It says 0, 4, 5. So when I set the 0 up, and again, I'll show you numerically how that works, but think what's going to happen in these guys right here. One of these 3 things is going to end up being 0, and that's an easy number to calculate. 0 times, who cares, is 0, right? So let me show you how that expansion looks. A word of caution when we do our expansion is we're going to have a series of alternating signs, but we got to be careful based on the row that we pick. It might not be plus, minus, plus. It might be minus, plus, minus, for example. So you just got to be careful when you do that. So let me kind of come down here, and I want to expand it around the 0. So remember, in that chart, that middle row was minus, plus, minus. So when I expand it around 0, it's negative 0. I know negative 0 we don't have to worry about, but anyways, the 4 itself is positive, and the 5 then is negative as far as setting the determinants up. Okay, and so then I get negative 0. Yes, I'm going to keep writing negative 0. And then I'm going to set up the determinants here. Okay, so when we put our where 0 is at, so I'm going to ignore the row and column that has the 0 in it, and I'm just going to write down the other numbers. So for the 0, that would be 2, 3, and the 0 and the 3 on the bottom piece. For the 4, so think of it like that cross in the middle, I want the 4 corner numbers, the 1, the 3, the negative 2, and the 3. And then for the 5, again, ignore the row and the column that the 5's in, and I want to worry about the other numbers, which is 1, 2, negative 2, and 0. Okay, now I'm going to say that negative 0 is 0, and then who cares, right? Because that whole thing is 0. So plus 4 times 1 times 3 minus 3 times negative 2. So I'm just definition of 2 by 2 determinant. Minus 5 times 1 times 0 minus 2 times negative 2. All right, and I carry out the math on that. That would be 3 plus 6, so that's a 9, minus 5 times, let's see, that would be negative 4. Okay, sorry, caught my mistake here. when I multiply a negative 2 times a negative 2, I actually get a positive 4. So it's 5 times, subtract 5 times 4. So we get 36 minus 20, and I get, the same 16 that we got earlier. All right, the same number up here. Okay. Now, this whole idea of the plus minus, coupled with the 0 idea, is gonna end up saving us some time when we look at more complicated determinants, like for example a 4x4, which was our goal. All right, so this is what we actually started off this adventure with, is to get to this guy. So notice it has the same pattern as the earlier, the simpler cases, where I pick a spot and multiply by the determinant of the other numbers. So where A is located, I would multiply by the determinant of the 3x3 with F, G, H, J, K, L, and O, P, right? And then we still have that alternating sign, so positive, negative, positive, negative. And again, that whole cover up with the row and the column piece, that also is appropriate. And so you really want to, before you write out the problem, because think about how many steps this one took to get, and that was a single 3x3. So here, when I do a 4x4, I have to do that 3x3 process 4 times. So anytime I can work a 0 in, that's going to give me a lot smaller set of numbers to work with. So let me get an example up, and then we'll actually work through with the numbers. All right, so here's a 4x4 that we are going to find the determinant of, and we want to start by looking for zeros. Where do I have the most number of zeros, either row or column? So up top, I could do the 1, 2, 3, 4 thing, in which case I would have 4 3x3 determinants I'd have to simplify. I could go to row 2, and row 2 I'd have a 0 to start off with, and then 3 determinants. But take a look at row 3. Row 3, I've got 2 zeros in. That's the key. I'm going to go with that row because that'll eliminate half of the work. Even going up in the columns. So if we look in the columns, I've got a 0 there, a 0 there. So any column I pick, I have 1 0, but there's only one place where I have 2 zeros that I can take advantage of. Now, you might not have a 0, and if you don't, you just got to suck it up and take the patience to work out all of the 3x3 determinants. But in this case, I'm going to show you how this works. So before we get too excited, though, we got to work out that plus minus thing, because that will make a big difference at the end. So we start with a plus, and then a minus, and then a plus, and then a minus. Now that should alternate underneath it, plus, minus, plus, and that should alternate, and that's our target row right there. So when I set the determinant up with that 2 and the 4, the 2 is a positive number and the 4 is a negative number. Okay, so let's do that. So we get 2 times the determinant of the remaining 3x3, which we'll go in and identify those numbers here in a second, minus 4 times the determinant of its little partners. And actually, I can totally cheat here. Just do the copy paste thing. Okay, plus 0 times, well, honestly, are we going to worry about that? Not really. And then minus 0 times, again, same logic. So again, I'm expanding around the 2 and the 4, and so that eliminated half of these, half the steps. Okay, now with the 2, so I'm looking at the 2, I ignore the row and column that the 2's in. So here's that row with the 2, 4, 0, 0, and there's the column with the 1, 0, 2, and negative 4. So I ignore it, and I'm going to write down the other numbers around it. So 2, 3, 4, and then negative 3, 2, negative 1, and then below I have 0, 7, and 1. Okay, and then with the 4 here, so there's the column with the 4 in it, there's the row with the 4 in it, so I want the 1 and the 0 from that little sliver above it, and then the -4 in the corner, so that's that first column. And then I want the 3 and the 4 and the 2 and the -1. 2 and -1. And 7 and 1 for the remaining two numbers. Okay. Now, just to give us a little bit of practice setting it up, even though the zeros are going to eliminate the actual finding the determinant, it's still good practice to get used to how to find the other missing numbers. So in this zeros case right there, that guy, that's the target one, the one I'm trying to write the 3 by 3 around, I'm going to ignore the row it's in, I'm going to ignore the column it's in. So I want this set of numbers, the 1, 2, the 0, and the -3. So that's that set, and then I want the numbers below the row, so -4 and 0. And then what's left, so I've got the 4, the -1, and the 1. Okay, and then this last 0, so this guy right here, I want that chunk of numbers there. So the 1, 2, 3, and then the numbers underneath it, so 0, -3, 2, and then -4, 0, 7. Okay, so now we got that done, we can then focus on these smaller determinants. Okay, so at this point, we just have to worry about those two guys, right? And what's even better is there's more zeros to take advantage of. Look at that. We have a 0 here, so we can expand around that third row. And here we have a 0 in the middle, so we can expand around that second row. Okay, so let's remind ourselves of the signs. In particular, we're just going to worry about, instead of that column there, it's not present in a 3 by 3, so it's a plus, minus, plus, minus, plus, minus. Okay, so when I expand around the 0, 7, and 1, I get the 0 is positive, the 7's negative, and the 1 is positive. So 2 times, and so we got another set of parentheses, so 0 times the determinant. All right, bear with. All right, we're going to do a 2 by 2 around it. Okay, and then it's a minus 7 times the determinant. Oops, I got ahead of myself. I was trying to set up so we go back and fill in those numbers. All right, so let me get that. All right, so minus 7 times that guy, plus 1 times that. And we'll come back in and fill in those blanks, and then we have minus 4 times, and now we get to pick the row we want to expand around, and we're going to pick around that 0, 2, -1, which is a negative, a positive, a negative. So it starts off as -0 times the determinant, then it's plus 2 times the determinant, then minus, should be minus times the -1 times the determinant. Sorry, I got that built in there. Okay, so now we just get to go fill in a big giant bunch of numbers. Okay, so going back here, around the 0, so we eliminate the row and the column. So it's 3, 4, 2, and -1. And then we have around the 7, so it's this set of numbers. So 2, sorry, said it and then didn't type it. 2, 4, looks like -3 and -1. So again, we ignore the row and the column that 7 is in, and we want the other two sets of numbers there. And then this 1, we ignore that column and that row, and it's the 2, 3, -3, and 2. And then we come over here to this one, so the middle row here. So we ignore the row that has a 0 and the column that has a 0, and then it's the 3, 4, 7, and 1. Then I ignore this little plus in the middle where the 2 is at, and it's the 4 corner numbers. So 1, 4, -4, and 1. And then, sorry, I just realized that it's not a times, it should be we're adding the negative. It's going to be a positive 1. We'll get there. Okay. And so then it's this -1 that I'm staring at. And so I want the 1, 3, the -4, and 7. Well, it helps if I type what I said. 4 and 7. Okay. All right, so then we just go back and address what we need to address. Now this piece, that guy, that's 0. So it's -7 times, and then 2 times -1, subtract 4 times -3. And that's the 7 one, and then it's +1 times 2 times 2 minus 3 times a -3. And then so that's all for the 2. So once I figure out that inner number is, then I'm going to double that and multiply that by 2 on the outside. So it's -4 times, and again, this piece I can ignore because it's 0. And then 2 times, and then 1 times 1 minus 4 times a -4. That will become a 1 times 1 times 7 minus 3 times a -4. All right, and then you want to go in and do a little bit of simplification there. Okay, so I'll kind of let you check the numbers here and just confirm that I didn't make a silly mistake, but 2 times -1, subtract 4 times -3 should give you 10. 2 times 2 is 4, plus a 9 should give you 13, etc., etc. All right, so when you distribute, multiply, carry it all out, you should end up with -326, which is the determinant of the original matrix. So hopefully this helped.